Hello, I'm Jim Hall. I'm a sales engineer. Actually, my buddy Chris, who works in the media and entertainment vertical in the US office, he and I actually put this together, but I'll be presenting. So today I wanted to talk to you about BBR, the benefits and risks for streaming. I do apologize. Actually, this presentation was actually supposed to be the presentation of the results of a major experiment that we're doing with one of our customers. However, there was a developer's issue and they're not ready yet. So what this will be is the first half where we sort of talk about what the advantages and risks of BBR are. And then I'll do a follow-up presentation, if Phil is willing, where I'll show the data that we got from the Fastly customer. So I'm going to talk about quickly about TCP congestion and Cubic, what is BBR, how to enable BBR, some of the experiments that have been done outside of Fastly, some of the caveats, and the future of BBR. And because we're running out of time, I'm going to be fairly quick. So first, TCP congestion and Cubic. So what is TCP? TCP stands for Transmission Control Protocol. It's basically how computers talk to each other over most networks, including the internet. TCP is responsible for creating and destroying connections. It breaks the data flow down into packets, readily consumable chunks of data, if you will. And it ensures data integrity. If a packet is sent and not acknowledged in a certain amount of time, TCP will retransmit that packet. And retransmission factors in heavily into some of the algorithms that are used to manage TCP. So the algorithm that we use at Fastly and is fairly heavily used around the internet is Cubic. And one of the nice things about Cubic is it strives very hard to be fair. And by fair, I mean it strives to provide equal distribution of the connection to all connections using that. So it tries to scale up and down so that no one connection is consuming the entirety of that connection. It uses congestion events to increase the congestion window, and as it detects packet loss, it scales back that window. A standard congestion algorithm for Linux, as I mentioned, it's the default at Fastly, and it works great, except in high latency lossy networks, things like mobile networks, remote areas, etc. So how do you measure congestion and help performance in these networks? Cubic is great because it scales quickly. It scales cubically as opposed to additively like Reno and multi-CP. Cubic starts to scale back, though, the bandwidth. It starts to scale back the bandwidth as soon as it detects retransmission requests. So there has to be a better way. And so along comes BBR. So what's BBR? It stands for bottleneck, bandwidth, and round-trip propagation time. Really rolls off the tongue. It is another TCP congestion algorithm. It's open source. It was developed by Google, and it's currently in version 1. So it's kind of the new hotness, and I'll show you some examples of why. It uses a combination of factors to estimate congestion. It uses recent measurements of the network's delivery rate and round-trip time. It builds an explicit model that includes both the maximum recent bandwidth available to that connection and its minimum recent minimum recent round trip delay. It uses this model to control both how fast it sends data and the maximum amount of data it's willing to allow in the network at any time. BBR largely ignores retransmission. And if you remember, Cubic, as soon as it detects retransmission, it starts scaling back. It does not accept, BBR doesn't take retransmission as an indicator of packet loss. Instead, it's looking more at the round trip time, RTT. BBR is much better at keeping the network hovering at the ideal point, which is just below saturation, the connection saturation. Whereas some of the older Reno, multi-CP, and Cubic, what they actually do is they cross the saturation threshold and then scale back. Whereas BBR strives to be just under saturation. So what does this mean in practical terms? What does this mean in terms of video delivery? So for video, it reduces rebuffering, especially in developing countries and on mobile networks. It's not as impactful in or on more advanced networks like in the EU or North America, and it's not great with Wi-Fi networks. So if it's not great or doesn't have as much improvement, why still use it? Well, because every little helps. And sometimes, 3 or 4% improvement in rebuffering can have a substantial increase in things like your quality of experience score. BBR reduces median RTT by 53% on average globally, and by more than 80% in the developing world. That was a quote from our friends at YouTube. So how do you enable BBR? On Fastly, it's pretty straightforward, but before we get to the CDN, it's important to note that BBR does not require any special software. You don't have to modify your player. You don't have to use a special browser. There's no requirement for routers or switches or clients to support. It's completely defined by the sender, in this case, the CDN. So basically, it's your CDN that needs to support it. Fastly supports it. Edgecast also supports BBR. Does Cloudflare support BBR? Thank you. I'll update that. So on Fastly, it's actually pretty straightforward. You go into your VCL and in VCL deliver, you set the client socket congestion algorithm to BBR and you're done. That's sort of the simplest possible way to do it. There are some other ways of doing it in terms of this is how you enable it, but you might want to change your conditionals, and you might want to do things like if the AS number, the autonomous systems number, is in a list that supports or benefits from BBR, then enable it. But if you have evidence that says that an AS number does not do well with BBR, then you might want to blacklist it and not enable BBR. There've been a fair few experiments with BBR. Legal made me erase the customer name, but Phil already mentioned them, and they gave a talk at London Altitude at Fastly earlier this year. A very large streaming audio customer experimented with BBR, and what they found was that in APAC and LATAM, rebuffer decrease was 12 to 17%, and that's huge. That's a lot of happier customers and audience members for your content. Bandwidth increase was 15 to 25%, and the 10% was the median. In North America and the EU, not as much of a difference, but still a significant difference in my view. The rebuffer decreased 3 to 5%, and the bandwidth increase was 5%. Some other experiments have been done with a large media publisher, a US-based media publisher, and it was just website delivery. And one of the reasons why I include this is because it's not just for video. BBR isn't some magical thing just for large files, it's in general. So they had an average visually complete time across all verticals, 342 milliseconds, performance improvement or 5%, and every vertical improved by at least 55 milliseconds, some as much as 700 milliseconds. Wait time was 2 milliseconds or 1%, dot complete time 53 milliseconds or 3%. So how do you test BBR? Something's gone out of order. So before we talk about testing, in the lab, BBR has proven to be incredibly greedy, to the point that it will, again, in the lab, block out any other connection and just hold on to it for itself. But what we found at Fastly is what was happening in the lab is not what's happening in the real world. And so what we're doing is working with one of our customers to, on a very large scale, for video, not audio, test the impact of BBR and what its impact on a network connection might be. We don't want to saturate our links to the origins and or to the end users. So how do you tell if BBR helps or hurts? First of all, you do A/B testing. You use RUM data and you use CDN logging. And ideally, you join up the RUM data with the CDN logging, use UUIDs. On the RUM data side, you want to look at, you want to use something like either MUX or Ubora or Bitmovin to analyze the end user quality of experience. MUX and Ubora, I don't know if Bitmovin does, I think they do, have an overall quality score. It's a number, which basically acts as a barometer for is your, the quality of your stream. You want to look for improvements there. Specifically, you want to start looking at things like, are you getting higher quality renditions? Are your users seeing an increase in the either the bit rate or the frame size in their renditions as a result of BBR? You want to look at rebuffering frequency. You want to, or reduction in rebuffering frequency. You want to look at rebuffering duration. You want to see a reduction there. Things like time to first frame, you want to see that reduce. On the CDN logging side, you want to look at things like time to last byte, or TTLB, time to first byte, or TTFB, your delivery rate, or the bandwidth that the connection is actually, the connection, the bit rate at which the object is being delivered to the end user. You definitely want to keep an eye on round trip time to see, are you getting better round trip times or worse round trip times? You want to keep an eye on your retransmission count. And lastly, you want to do all of this by AS number and geography. I also want to stress that not a lot. What we're finding is at Fastly, we actually have to convince customers that their CDN logs are actually worth looking at. A lot of people do not, they're looking for things like 404s or 503s. They're not looking at a lot of the data that is available, such as round trip times, such as bandwidth or available bit rate, et cetera, et cetera. And we're now taking it a step further. Now that we've got a lot of our customers actually appreciating the value of CDN logs, what we're saying is, if you're using something like Bitmovin or MUX or Ubora, what's important is that you start connecting them up. And to do that, you can use a UUID generated by the video player that's either passed as a query string parameter or as a header. And what it allows you to do is you can get down to a specific end user and look at every single request that they received and look at how it performed. And you have a story for that end user and get an idea of how good or bad their experience was and whether or not BBR was an improvement or a failure. So there's caveats of BBR. So as I mentioned, BBR attempts to actively defend itself in order to prevent it from being crowded out by the concurrent operation of conventional protocols. By conventional, Cubic. So it's in the lab, it's greedy as you know what. But like I said, at Fastly in production, we're not seeing that. We have yet to identify an issue created by a customer who's using BBR, nor have we identified the use of BBR causing issues by one customer impacting other customers. However, Fastly caveats the crap out of it on its page that it should be used with caution. It's very aggressive. It can destroy neighboring Cubic flows. There are actually environments where Cubic outperforms BBR, so you should use it with caution. Again, you can do things like when you start analyzing your logs, you can start building a list of AS numbers, for example, where BBR actually works really well and others where it doesn't. And you can use that information to build an edge dictionary that allows you to look up what to do. So you can use a little bit of log analysis. I don't want to say machine learning or AI, but you can know whether or not it's going to have a benefit. And you can build lists that you can look up and make a decision on the fly whether or not to use BBR or not. So what's the future of BBR? It's still in development. BBR v2 is currently in alpha. It seeks to incorporate packet loss into the algorithm, and it's friendlier to neighboring connections. We still don't know, Fastly hasn't made a decision whether or not to enable v2 of BBR, but given that we already have v1, I suspect we will. If you have any questions or would like to learn more about BBR, let me know. I will send you a bunch of these links that you can inform yourself, but you can do a quick search on the interwebs. You'll find information from Google. You'll find the Spotify blog post on it. You'll also find the video that Spotify gave at Altitude in London earlier this year. Are there any questions? Yes?